Good day. All right. In this video, I want to talk about question 6B from PSPM 22-23 for the second semester. All right. There's the word lens in that. So I just want to remind you that there are three parts of geometrical optics. All right. There's going to be mirrors, spherical mirrors. There's going to be spherical refraction, so refraction on spherical surfaces. So refraction. And then the third part is going to be on lenses. So this part is going to be on lenses. Okay. In lenses, we have two main equations. You have 1 over f equals to 1 over u plus 1 over v. And then you have a second equation of and material of the lens over and medium of the lens, right? Medium minus 1, and then 1 over r1, which is the radius of the first surface, and then minus 1 over r2, which is the radius of the second surface. So I just want to remind you that there are two equations to determine the focal length, right, in lenses. All right, so now let's look at the question. A biconvex lens. So biconvex simply means that it looks like that. Okay, has surfaces of radii of curvature 18 and 20. Okay, when an object is placed 24 centimeters, right? So I just want to point out this will be your R1. You can choose that, okay, this is going to be my R1 and this is going to be my R2, right? When the object is placed 24 centimeters, that's going to be your U. A real image is formed 32 centimeters from the lens. So that's going to be my V. Okay. Determine the focal length. Okay. Now, if you look at this question, we do not have the refractive index of the material at this point. We don't see it yet. So we will have to use the first equation. So first equation. Okay, so we are going to, let's just going to write that down. 1 over f equals to 1 over u plus 1 over v. My object is real, so it's going to be positive. So 1 over plus 24. And then my image is also real, so 1 over 32, right? Plus 1 over positive 32. And that gives me a focal length, right? A focal length of 13.7 centimeters. How do I know it's centimeters? Because the 24 is in centimeters, the 32 is in centimeters, therefore my f will also be in centimeters. So that is the solution for part 1. For part 2, right, we can assume that this is going to be in air. So the medium is going to be 1. Okay, and then I'm going to take the 18 centimeters as R1. So if I were to just draw out, right, like that, that's the first surface. My R1 is going to be here, which is 18 centimeters. And then let's just change colors to green probably. Okay, yep, let's just use green. And if we extend the second surface here, right, I can see that the radius is on the opposite side. So R2, which is equals to 20 centimeters, is on the other side. So that will be negative. So that is going to be negative. I'm just going to remind myself that now I don't want to be substituting the wrong answer. So my R2 is negative 20 centimeters. So I can substitute these values, right, into equation 2. So equation 2, I will have 1 over f, right, which I know. Okay, and then my medium is just 1, so I'm left with the material minus 1 over r1 minus 1 over r2. So I know my f is 13.7 The material, the refractive index of the material is what I'm looking for. So -1 there. And then the first value, my R1, is positive 18. And then minus 1 over negative 20. The reason why it's negative, because its radius is on the incoming light ray side. So this is my light ray. Okay. Now, if you were to solve that, what you're left with is that the refractive index of the material is 1.69, and that is your final answer. All right. Okay, that is all from me today. Or no, that is all from me in this video. Thank you very much.